Okay, everybody. This right here is number 7 on page 2. So if you have not done number 7 on page 2, do that first. Do number 7 first on page 2. Number 7 first on page 2. Pause it if you need to pause it now. All right, here we go. I'm hoping this is, when we finally get to these, this is where people, I think, a light bulb may start coming on here for some of us. Because now we have quantitative graphs. We have quantitative, which means there's numbers here. And that means that that line right there has a very specific what value? A very specific slope value. And again, I'm going to remind you once again, the slope of this graph tells us what? Again, I hope that you're getting faster in your mind at thinking of this, because that tells us the velocity. The slope of this graph right here tells us the velocity. So we need to find the slope. Hopefully you've done it. Oh, hold on, there's one other thing. One other thing. I also want you to sketch a motion map. If you haven't sketched a motion map for this, do that now. And not just this one. You will also sketch a motion map for numbers 5 and 6 when you do those. So, motion map, as well as figuring out what the velocity time graph looks like. Okay, so pause it, create a motion map, and then come back. All right, so we got to find the slope of this line. Well, this right here, dun, 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 dash, 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 that is the rise. And how big is the rise? Looks like 4 meters. Use units of measure. Please use units of measure. And then it looks like our run is right there, which is what? Oh, that looks like 4 seconds. I hope you can see clearly that the velocity in this case, or the slope, which is the velocity, is 1 meter per second. And more specific, I would say this. What kind of slope is this? What kind of slope? That is a positive slope. I hope that's the word you were thinking when I said that. Positive slope. Boom. Now, on our velocity time graph, where is positive 1 meters per second? Oh, look at that right there. So that's where we're talking about. Plus 1 meter per second squared, or meters per second. Did I say squared? Jiminy Christmas. So, 1 meter per second. Now, does it stay that way? Does it go up like this? No, that means the velocity will be getting bigger. It isn't getting bigger. The position's getting bigger over here, but the velocity is the slope, and the slope is constant. It's constant 1 meter per second. So on my graph here then, I would take the old pen, and I would start at the 1 up. Oh my gosh. This is terrible. I would start at the 1 up here, and I would draw a line all the way over till, well, till where? How far do I draw it? I would stop right there. Why would I stop right there? Because when I look at this graph, notice, we only have information that goes out to 4 seconds. We don't have anything beyond 4 seconds. Therefore, on my VT graph, I can't show anything more than the first 4 seconds. And this graph here says it was a constant 1 meter per second for the whole 4 seconds. I should say the first 4 seconds. Hopefully that makes sense. Sometimes it helps now when we finally start seeing numbers, some numbers here and some slopes that translate into specific places on the velocity time graphs. All right, we still haven't done the motion map, which I asked for. So how about motion map? Here we go. Dun, dun, dun. What does this motion map look like? Hopefully you already had paused the video and did it. If not, shame on you. So right there is the starting position at 0, because again, that right there is 0 position. So I draw an arrow like that. These are terrible arrows. And I draw another one like that. Well, that's a big point. I draw another one like that. How many more should I draw? Now, people in class were saying as many as you want. And I say, no, not as many as I want. I would say just 4 arrows. 1, 2, 3, 4 arrows, 4, 1, 2, 3, 4 seconds. That's what I would do. I would make the motion map match what the graph is showing. Everybody got that? Oh my gosh, that was less than 6 minutes. This is nice. This is going way faster than the other ones. I think that, yeah, I think we're good now. Now, at this point, you need to do numbers, or number 5. Do number 5. You do number 5. You pause, I'll pause, you pause the video, go do number 5, including a motion map, and then come back. I told you I'd be here when you got back. All right, so I'm going to try to make this all one video. Okay, I just got to shut up and work. All right, now the first part, remember, motion map. Well, no, let's not do the motion map first. Let's look at the graph here. This graph shows we have 2 separate steepnesses. We have one steepness here for 1 second, and we have a different steepness here for the next 4 seconds. So we have 2 different steepnesses or 2 different values for slope. And again, I'm going to write this out again. Slope of this graph, slope of position time graph, is what? Velocity. So, whatever words you use to describe the slopes here, that's what's describing the velocity. And so, if I look at this graph and I see ... I have a certain rise here, and then I have a certain run. What's my rise and my run for the first section? Well, my rise is 2 meters, if you're looking. And the run is what? 1 second. So what is my velocity for the first part? Yes, 2 meters per second. Now, more specifically, it's positive. Because again, that is an upslope, therefore it's positive. Now, how do I translate that onto my velocity time graph? Well, where is 2 meters per second? Oh, it's up here. Now, how long is it doing that? I hope you see that it's doing that for 1 second. Just 1 second. So your line on the VT graph should only go to the 2 meters per second. Wait a minute, can I change colors on my laser pointer? Oh my, no. What? Nope, apparently not. What on earth is that? I don't even know what that meant. That was like a lightsaber. Okay, so anyway, 2 meters per second, positive 2 meters per second, and that only lasted for 1 second. Notice, that only lasted for 1 second, and then the slope changed. Okay, so now we got to figure out another slope. Hopefully you did this. So we figure out the slope of the second part, like this, like this, like this, and like this, and like that, and like this, and like that. And so, what's my rise? That would be my rise, and my rise is 2 meters. What's my run? Well, that would be this, which is what? 4 seconds, which gives me a velocity of what? 0.5 meters per second. What the meters per second? 0.5 meters per second. Okay. So, now, oh, that's also positive. That's a positive slope right there, and so this is also positive 0.5 meters per second. So where on my velocity time graph do I have to go? Well, I go to 1/2 of a meter per second squared. 1/2 of a meter per second squared. Where's that? Right here-ish. Now the question is, where do I start my line? Does it start all the way over here at the 0 like the last one started? I hope you're thinking about that and thinking no, because it wasn't this steepness over here at 0 time. It wasn't that steepness until 1 second into the time period. So the first second this happened. From 2 to 5 seconds, this happened. So that means I don't start my line on this graph here. I start it here, and then I go across. So I got to go here like this, and then, oh gosh, and then draw it at 1/2, all the way to 5 seconds. Now, why do I go all the way to 5 seconds this time, but I didn't last time? Because this one goes all the way to 5 seconds. So we have that information, so we put it on there. Half a meter per second, 0.5 meters per second, positive, for the other 4 seconds. Got that? Hopefully you got that. All right. Hey, do number 6 now. Pause the video, do number 6, and I will be right back. I forgot about the motion map. Almost forgot about the motion map. So, here we go. Motion map, right there, 0, positives to the right. So, question, where did the object start? Oh, look at that. Started at the 0 position at time 0. So that means I put my first dot where? On the 0 position, right there. Now, what direction is it going? Well, positive direction. As we see, we have a positive 2 meters per second. Now, that's pretty fast. It's way faster than this. So my first arrow is going to be what? I'd say it's going to be pretty long. Positive 2 meters per second. Now, here's the thing. My next arrows are going to be what? They represent way slower. Now only 0.5 meters per second, and that's still positive, so my arrows are still in the positive direction, but now my arrows have to be short. Like maybe a fourth of what these first ones were. First one was. And one more for the 5th second. There we go. So that now shows that it was really fast for a second and then it was slow for the remaining 4 seconds. Now, in the next part of the video, I'm going to say, oh, I forgot to do the motion map on the last problem. And then I just went back and edited it and added it in. So you're going to think I'm an idiot when I said I forgot when you just saw me do it. Whatever. I don't really care. Well, I got to get out of here. Here I am. I'm back. All right, finally. I didn't think we were going to get done. But hey, we're about there. Let's see. Let's go with, I guess I'll use my laser pointer. So my laser pointer is telling us now that this right here is one slope, and then this right here is another slope. But here's the deal. Now, not only do we have 2 separate steepnesses, we have the line tipped 2 different ways. Now, we have to think about what the implications of that is for our VT graph, but we'll get there. All right, first of all, first things first. Oh, motion map. No. Yes, let's do the motion map first. Question. Where did this object start? Oh, wait a minute. I didn't draw the motion map on the previous graph. Oh, my. I may have to go back and fix that. Oh, that means if I go back and fix it, you're going to hear what I just said and think I'm an idiot because, oh, gosh, well, I can deal with it. See, if I go back and edit it, you won't ever know it wasn't there in the first place. But whatever. I don't even want to think about it. So, where does the object start in this on this graph? Hopefully you're looking here and you're seeing, hey, the line does not start at the origin or the 0 position. It starts way up here at 2 meters, which means on my motion map, I can't start at the 0. It has to start out here at 2 meters. Okay, wherever that is. So my first dot has to be out here in a positive position. And it's traveling, oh, sheesh. Okay, I take it back. We're not doing the motion map first. I'm finding the slopes first. Back over to the graph. My apologies. Jeesh. All right, so I have a rise and a run. How tall is my rise? Looks like 2 meters. It goes up 2 meters. And how far did it go over? It went over 2 seconds, which means my slope in the first part, my steepness, is, that's a colon, it's not an equal sign, is 1 meter per second. And again, more specifically, what kind of slope is it? Positive. So I put a plus 1 meter per second. And where do I put that over here? I go to the 1, positive 1 meter per second, and I draw my line. And how far over do I draw it? Hopefully you're thinking 2 seconds, because that's how long the time went by that it was doing that. Then we got to go to the other section. Now the other section, we have not a rise, but a fall. And we still have a run. We have a run, but we have a fall. And so how big is that right there? Oh boy, that's terrible. How big is that? That's 4 meters. More specifically, that's negative 4 meters because it was a fall. It decreased in position, or it changed position in the negative direction, so that's negative 4 meters. And how long did that take? That also took 2 seconds. And so what is my velocity for this section? Well, it's 2 meters per second, but it's not just 2 meters per second. It is negative 2 meters per second. Hopefully you're getting that. And that means I got to go over to my graph here, and where is negative 2 meters per second? Right there. But when does that start? Oh, it doesn't start until 2 seconds in. 2 seconds in is when it's traveling at 2 meters, negative 2 meters per second. So then I draw that. How far over do I draw it? Only until 4 seconds. And why is that? Because that's when that line stops. We don't know anything after 4 seconds. Got it? Oh, great. Now, back to the motion map. The reason I waited is because our arrow length, the arrow length on the motion map is going to have to be determined by how fast. So, I do know it starts at a positive position, traveling in the positive direction with a velocity of, well, I guess that'd be 1 meter per second. For 2 seconds it did that. Then what happens? It turned around. How do you show it turned around? You put arrows that are pointing to the negative direction. But where do I put my arrows? Do I put them over the top of these going that way? No, I'd put them down right below. Right below. Just like when we put the dots for standing still, dot, 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 dot. I would, at the end of this arrow, I would put the dot. The next dot would be down here, only it would be traveling in the opposite direction. Now, opposite direction because it's negative, but it's also 2. 2 compared to 1. That's faster. In fact, that's how much faster? Twice as fast. So that's twice as fast. So my arrow has to be what? Twice as long. So that's my dot. Twice as long. Oh no. Oh, this is going to be a problem. Oh man. We got issues. Oh no, I got to erase this a little bit. I made that too long. There, and then another one right here. There we go. Now, I want you to see what happened here on my motion map. I started out here, went there after 1 second, there after 2 seconds, then changed direction. That was the 3rd second. That was the 4th second. Where does my arrow end? My arrow ends at the 0 position, which is right where the line was here, at the 0 position when time was 4 seconds. So for my 4th dot and arrow, it ends at the 0 position. What a thing of beauty. Now, at this point, this has taken forever, but I don't really care. So we have the first and the second page done. What I would do if I were you at this point, I would go ahead and do page 3. I believe page 3 has a data set and it has a grid, actually 2 grids, one for the position time graph, one for the velocity time graph. So, and then some other questions in there. So try to figure that out as best you can. And there won't be a video for that part. You just finish that sheet and then we'll be done. So I'll see you whenever I get back. Hope it wasn't too painful.